Hello everyone, welcome back to today's tutorial. We are dealing into the world of statistics as we explore three fundamental measures for mean, median and mode. So understanding these measures is crucial for anyone dealing with data analysis. So join me as we unravel the concept and implement them in Python. So let's get started. So the basic of mean, median and mode. Okay. So mean, median and mode are the measures of the central tendency, helping us understand where the center of our data lies. Okay. So the explanation for the mean, the average value, and median, the median value when the data is stored, and third is the mode, the most frequently occurrence for values. Okay. So first I am calculating the mean in Python. So let's start it with the mean, the average value of our data set. Okay. So let's get started. So now I'm create for is the data is equal for then 12, 18, it's 14, then 20, and then create is the 16. Okay. So now I'm create for is the mean value for is equal, then create for is sum, and the data for then division for is the len, object is data. Okay. And now I'm create for is the print function is print for the double quotation create is the mean value for the index is called for mean. Okay. So now this code is complete. So here the mean is calculated by summing up all values and dividing by the numbers of values in Python. So we use the sum functions and divide by the length of the data set. Okay. So now save this code and let me run this code. Okay. So the result is error, but why? Okay, so now I am just solved in this program. Okay, so then problem is fixed. So I am again for in this code for save. Okay, and let me run this code. So as you can see, the result is printed for the mean value is the 16.0. Okay. So next step I am creating for is calculating the median in Python. So next step the median value when our data is stored. Okay. So let's create it. So first time create is the sorted data. Okay. Is sorted underscore data then is equal for the sorted function for call is data. Okay. So now I'm create for is in equal for is the length for data is the sorted data. So now create is the median. Okay. Its median value then is equal for parenthesis create for sorted data and then create is the third braces for n and double forward slash for 2. Okay. And then create for is the plus sign for is the sorted data for again create is the third braces and then parenthesis create for n minus 1 and then double forward slash create for 2. Okay. And then inside I am create for is the 2. Okay. So it's completed and now I am print function used for f and double quotation create is the median value. It's median. Then index for its median. Okay. So it's code completed and here the median is found by sorting the data and selecting the median value. If the data set has an even number of values, the median is the average of the two middle values. Okay, so now save this code and let me run this code. Okay, so now as you can see, the median value is the 16.0. It's a match. Okay, so last one I am create for is the mean value. Okay, it's for the mode value. So the calculating the mode in Python is the lastly the mode, the value that occurs most frequently in our data set. Okay, so let's create it. So first of all, I am create is from, and then create is the statistic. Okay, a statistic. Then create for is the import for mode. Okay, it's mode. Then now I'm create for is the mode for underscore is the value is equal for then mode. Okay, and then create for is the data. Okay, so now I am create for is the print function, and print for f and double quotation create for mode, and then clone and index for the mode is underscore for the value. Okay, so its code are completed. So it's for then it's great for curly braces. Okay, so it's then starting and closing curly braces. So here the mode is the value that appears most frequently in Python. We can use the mode function from the statistic module. Okay. So now save this code and let me run this code. Okay. So now as you can see, the result is for mode is 12. Okay. Its code are completely creating. For you are the congratulations for the master the art of finding the mean, median and mode in Python. So these measures provide insight into the central tendency of your data. Keep exploring, and the remember for statistic is a powerful tool for data analysis. Okay, so thank you for joining me in this exploration of mean, median and mode in Python. Okay, so thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. Today we are diving deep into the world of statistics to explore one of the key measures of dispersion. So the dispersion is the standard deviations. So understanding the standard deviation is crucial for assigning the spread of data points. So join me as we demystify the concept and implement in each data for Python. So let's get started. So the topic is the need for standard deviation. So your question for is the why do we need for standard deviations? Okay, I'm just explain. So well, it help us understand how spread out or clustered our data points are. So the larger the standard deviation, the more spread out the data is. Okay, so the standard deviation is two type is created for is the low standard deviation for the data point are close to the mean, and the high standard deviations means the data points are spread out. Okay, so now I'm create for is the standard deviations in Python. So the calculating for is the standard deviations involves a few steps, but we are not, and Python makes it easy for us. Okay, so let's create it. So first of all, I am create is for import for math. It's math. And now I am create for is the data is equal for then it's 12. Then create is 18, 14, 20 and 16. Okay, it's the data. Next step I am create for is the mean value for is equal the sum. Then create for is the data. for is the divide for, then create is length is data. Next time create for the variance. Okay, its variance is equal for the sum, and create for x minus then mean value. Okay, so now I'm create for is the double into for 2 is for x in data. Okay, so now I'm again for is the for slash is length for data. Okay, now I am create for is the standard deviation, short form is the STD, and then underscore for the deviation. Okay, its create for deviation is equal for, then math dot is sqrt function call is the variance. Okay, so now I'm create for is the print function, then if and then create for double quotation, create for the standard standard deviation. Okay, and then create for clone, and the index for the std is deviation. Okay, so its code are completed. So here we calculate the standard deviations by finding the variance and taking the square root. The variance measures how far each data point is from the mean, and standard deviations gives us a more interpretable matrix. Okay, so now save this code and let me run this code. Okay, so as we can see, the result is printed. For the result is the standard deviation for 2.8284 is the something its value. Okay, so in this tutorial you are created the first program and say for congratulations. So you are the master the art of calculating and interpreting standard deviations in Python. So either you are analyzing stock price or in this scientific data, and standard deviation is your key to understanding data spread. Okay, so keep exploring and happy coding. So thank you for joining me in this exploration of standard deviation in Python. So thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. We are delving into the world of data analysis, and we will be exploring the crucial statistical concept for percentage. Okay, so understanding the percentage is essential for gaining insight into the distribution of your data. Okay, so join me as we demystifying the percentage and implement them in Python. So let's get started. So the importance of the percentiles. Okay, so they provide a way to divide and understand the distribution of your data. So either you are analyzing for exam scores or stock price, percentiles help us to answer questions like the what percentage of data falls below a certain value. So now suppose I am in this explanation for this question. So 5% is the 25% of data is below this point, and then 5% for the median is that 50% of data is below this point, and third point is the 75% is the 75% of data is below this point. Okay, so now I'm creating for is the percentiles in Python. So the calculating in percentage involves storing its data and finding the value below which a give percentage of data false. Okay, so now Python makes this process is straightforward. Okay, so let's create it. So first time create is the import for is NumPy as as NP. Okay. So now I'm create for is the data is equal for, then the data for is 12, 14, then 18, 20, and for 16. Okay. And now I'm create for is P for percentage underscore is 25 is equal for the NP dot is create for is the percentile. Okay. Then create for it's not, then dot for is the it's for percentile. Okay. So now create for is the data for it's the 25. Okay. So now I am again create for in this code for copy and paste for next line. Okay. So I am just change it for is that P underscore for 50% and the percentage data for is the it's for data for 50. Okay. So this is the median value. Okay. So last one I am create for is the P underscore for 75% and then NP dot percentile data for is the 75. Okay. So now I am create for is the print function, then create for F and double quotation create is for 25. It's the percentile and clone, then create for index for P underscore 25. Okay. So now in this code for copy, okay, and paste for next line. Okay. And just change it is for the it's 50% and it's the 75%. And that change it for the value is the median. Okay. In parenthesis closing starting closing for is the median value, then median value is the 25. Okay. And then last one is the 75. So here in this example we use the NumPy library to calculate the percentiles. The percentile function takes the data and the desired percentile as argument, providing us with a powerful tool for analyzing data distribution. Okay. So now save this code and let me run this code. Okay. So just wait. Okay. So as we can see the result is printed for the fifth percentage is 25% is the 40 point and fifth is the 14.0 in 75 is the 14 is the result is same as and created. Okay. So next step I am create for is the visualizing for the percentiles. Okay. So visualizing the percentage can offer a clear understanding of a data distribution. So let's create a simple percentile plot using it's a matplot library. Okay, so let's create it. So in this create code I am create for is the import, then the matplot library dot is the py plot as then plt. Okay. So now I am create for the code is the plt dot create for is the box plot then data. Okay. Now I am create for is the plt dot is the title. The title is single quotation create for box plot width is the percentile Okay, and next time create for is the plt dot is the x level. For single quotation create is the data, and next time also create for is the plt dot for y level parenthesis for single quotation for create is the values. Okay, and last one I am create for is the plt dot show function. Okay, so it's created. So now here in this example we use the matplot library to create a box plot which visually represents the percentage. The box represents the entire quartile range and the line inside the box is the median. So this visualization helps us cross the spread and central tendency of our data. Okay, so now save this code and just wait and let me run this code. Okay, so just wait. Okay, so as you can see the result is printed. It's the is for, so it's the title is for box. Okay, so save and again run this code. Okay, so just wait. So this is the result for is the box plot with percentage using the visualizing percentage. Okay, so this is the result. So in this tutorial, I am create for the percentile Python in machine learning. Okay, so you are the congratulations. So navigate the world of percentiles in Python. So either you are analyzing the exam scores, stock price, or machine learning feature, the percentiles are your guide to understanding data distribution. Okay, so thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. We are embarking on a journey into the world of data distribution. So a fundamental concept in statistics and machine learning. So understanding how data is distributed, making informed decision in your machine learning involves. Okay, so let's get started. So first of all, I am the clear understanding the data distribution. Okay, so the data distribution is it's provide for insight into the spread, central tendency and shape of your data. Okay, so the data distribution is the spread, central tendency and shape. So the spread is how far apart data points are, and central tendency means the where the center of the data lies, and the shape the overall form of this distribution. Okay, so the types of distribution is the three types of distribution. The first type is the normal distribution and squared distribution, and last one is the uniform distribution. Okay, so the normal distribution is the bell shaped, is symmetrical, and k-way distribution is the asymmetry, and then last one the uniform distribution is the equal probability for all outcomes. Okay, so now I am visualizing data distribution in Python. So let's create for the visualization tools like the matplot help us make sense of our data. Okay, so let's create it. So first time create is import, and create for is the matplot library. Dot create is pyplot for as is plt. Okay, and now I'm create for is the import, then create for NumPy as for np. Okay, so now I'm generate the random data for the demonstration. So let's create for is data is equal for np dot the random dot is for normal, and then parenthesis create for 0, 1 and 100. Okay, so it's the normal distribution. And now I'm create for is the plot dot is used for histogram for hist is the data, and then create for is then beans equal for 30, and now I'm create for is the age color, its age color is equal, then single quotation create for is the black. Okay, So now I'm create for is the plt dot is the title, then is the parenthesis for the single quotation create is the histogram. Okay, is the histogram of data distribution. Okay, distribution. Okay, distribution. So now I'm create for is the plt dot for x level, then parenthesis for single quotation create is for values. Okay, next create for plt dot for y, it's plt dot y level, then parenthesis single quotation create is the frequency. Okay, and last one I am create for is the plt dot is show function. Okay, so now save this code, and here in this example I am create for Matchflow to use histogram, a powerful tool for visualizing data distribution. The example is the distribution is demonstrate a random data set with a normal distribution. Okay, so now save this code and let me run this code. Okay, so just wait. As you can see, the result is printed. It is the histogram of data distribution. Okay, so it's the frequency for in this data, and it's these values, and in this for the frequency for 2, 8, 6, 2, 4, 6, 8, 10, and 12, and it's the 0, 4, and -1, -2, and +1, +2, 3. Okay, so it's created. So next step I am create for is the descriptive statistic in data distribution. Okay, so the descriptive static help the quantify aspect of data distribution. Measures like mean, median, and standard deviation provide the numerical insight. Okay, so mean value is the average value, median for the middle value, and the standard deviation is the spread of data. Okay, so let's create it. So now I'm create for is the mean value. So let's start it. So first I am create for is the mean value. Okay, its mean underscore for is value is equal for np dot for mean, and the create for is the data. Okay, so now in this code for copy and paste for next line. Okay, so I'm just change it. It's the median value. Okay, it's median value for np dot the median. Okay, so now in this for the mode value. Okay, it's mode, then change for is the mode. Okay, so it's created. So now I am create for is the it's not mode use, I am just use for the distribution. Okay, std and underscore for the deviation, it's the deviation for is equal the np dot for std is called for is the data. So this is the median value and is the deviation. Okay, standard deviation. And now I am create for is the print function. Okay, then print for double quotation create is the mean value for its index for the mean value. Okay, now I am again create the print function, and double quotation create for is the median. Okay, it's median, then clone for index is the median value, and last one is create for is double not double quotation use. Okay, it's double not double parenthesis, and last one I am create for is the print function and parenthesis. Its parenthesis for if and double quotation create is the standard deviation. Its deviation, then call for is, then index for is steady deviation. Okay, so now complete this code, and here in this example I am creating this. So now save this code. Okay, and let me run this code. Okay, so just wait. So in this the histogram and it's closed now. Okay, so this is the result for in the mean value, median value, and the standard deviation value. Okay, so the code are completely run. Okay, so and there you have it, the navigated the landscape of data distribution in Python. So either you are a data scientist, analyst, or machine learning programmer, so understanding how your data is distributed in the compass for making informed decisions. So keep exploring and happy coding. So thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. We are diving into the realm of normal data distribution, a concept for that plays a pivotal role in the statistic and machine learning. So understanding the normal distribution is like having a secret key to unraveling the my stories of data. So join me as we explore what normal distribution and why it's used and how to work with in Python. So let's get started. So in this code, I am previous tutorial create for is the data distribution part. Okay, so the data distribution is type is for the normal distribution. So this code I am used for in this normal distribution tutorial. Okay, so the normal distribution is the also known as the bell curve for a beautiful and common pattern found in nature. Okay, so it's for the symmetrically central tendency, and it's for the rule is about 68% of data falls with on standard deviation from the mean, and 75 within 2 and 99.7% within 3. Okay, so first I am generating the normal distribution in Python. So let's bring the normal distribution to life using Python. The use for NumPy library makes it easy to generate data with a normal distribution. Okay, so first time create is the import for matplotlib library, then use for NumPy, and the generate for is the random data with a normal distribution for data in P, and in this code for same match. And now I am visualizing the distribution for is the histogram data, and beans for 30, and its color for black, and the title is for the normal distribution in Python. Okay, so in this for remove, just create for is the normal distribution in Python. Okay, so it's for same as frequency, and then values, and create for is the show function. Okay, so now save this code, and here in this example I'm used for the NumPy to generate the random data with a normal distribution for mean value is 0, standard deviation 1. Okay, the histogram visualization helps us see the bell-shaped curve. Okay, so now save this code and let me run this code. Okay, so just wait. So this is the result for is the normal distribution in Python. Okay, so it's for the values, and this is the frequency for in this tutorial, and in this for random normal coding. Okay, so next step I am create for and discuss the properties of normal distribution. The normal distribution has some the fascinating properties that make it a go-to model in various fields. The mean, median, and mode are all equal in a perfect normal distribution. Okay, so the explanation for in this normal distribution, mean equal median and equal mode. Okay, so the 68, 95, and the 99.7 rule is the Z-score for measures how far a data point is from the mean in terms of standard deviation. Okay, so now I am applying for in this the real world example. So the simultaneously examine scores and examine how they might be distributed. Okay. So let's create it. So first time create is a real world example. In this data is changed for the exam scores. Okay. Is exam underscore age scores and then equal for np.random for the value is 70. Then is create for the 10. Okay, and in this for 100 is the mean for 70 and standard deviation for 10. Okay, so now I'm create for is the plot dot histogram is the exam scores. The beans in 30 is for black is colored for black and the distribution of exam is distribution for the exam scores, the title. Okay, exam scores and then values for the scores and then last one is then y level is the frequency and the show for in this code. So in this example we simultaneous the exam scores with a normal distribution for mean value is 70 and standard deviation is 10. Okay, so now save this code and let me run this code. Okay, so just wait. So as you can see, the result is printed. For this is the distribution of exam scores. Okay. So this helps us the understand how exam scores might be distributed in a normal world scenario. Okay. So this the means is the mean value for 70 and the standard deviation for is the 10. Okay. So here in this tutorial, you are a journeyed into the heart of the normal distribution in Python. So either you are building for machine learning models or gaining insight from a data. So understanding the normal distribution is a powerful skill. And thank you for watching and happy coding. Okay. Hello programmer, welcome back to today's tutorial. We are talking a deep dive into the world of scatter plots, a powerful tool not just for visualization but a cornerstone in the machine learning journey. So in this tutorial, so join me as we explore how scatter plots help and uncover patterns, relationships and guide as the intricate of machine learning. Okay, so let's get started. So first of all, I am introduction to scatter plots in machine learning. So the machine learning serve as our the visual gateway to understanding relationships between four variables and either it's exploring feature correlations, identifying outliers or preparing for model building. For scatter plots are our guiding lights. Okay, so in this scatter plots is great for the correlation is the visualizing relationships between feature and outlier detection for identifying the unusual data point and the feature engineering used for the understanding feature distribution. Okay, so now I am generating the scatter plots in Python. So the creating for scatter plots in Python is not just a technical skill, it's an art. We will leverage the matplot library to craft for visual narratives with the that speak volumes and our data. Okay, so now I am create for is the generating for scatter plots in Python. First time create is the import, then create for is the matplots library. It's for dot for py plot as plt. Okay, so next time create is the import for pandas as pd. Again create for is import, then its create for is a c1 as s and s. Okay, so now I am create for the lead a sample data set for replace with your data set. Okay, So let create is div equal for ns dot load underscore dataset, then single quotation for Irish. Okay. So now I'm create a scatter plot. So first create is sns dot the its scatter plot. Okay. So now I'm create for is x equal, then single quotation create the sepal length. Okay. It's sepal underscore its length, and then create for is y equal for create single quotation create the sepal width. Okay. It's sepal underscore its width. Okay. So next time create for is the here. Okay. Then it's equal for single quotation create the space. Okay. It's space. And last one I am create for is the data for df. Okay. So it's code complete. Next time create for is the plt dot, it's the title, then title is create for parenthesis and single quotation create is the scatter is plot, then semicolon create for is the is first create is sepal length versus its length. Okay. And next time create is the sepal for width. Okay. Its width. So now I'm create for is the plt dot for x level is for then parenthesis and single quotation create for sepal length. Okay. Next time create for is the plt dot y level create for single quotation, then it's for the sepal width. Okay. And last one I am create for the plt dot show method. Okay. So now this code create completely, and in this it's space. Okay, it's complete. So here in this example we use the matplot library and seaborn library to create a scatter plot using the famous iris dataset. So this plot visualize the relationship between the sepal length and sepal width. Okay. So with the color coding for different space. Okay. Now save this code and let me run this code. Okay. So just wait for, okay, seeing this for error. So I'm just in this fix for indicate. Okay. So in this for the df for SNS is load dataset, I am extra create for ace. Okay. So it's now in this code for is perfectly, it's perfect. So now save this code and again run this code. Okay. So just wait. So as we can see, the result is printed. So this is the result for is the scatter plot for the sepal length and the sepal width. Okay. So it's for 6.0 is indicate for x level, and it's the 3.0 is indicate for the y level. Okay. And in then color is the different color for color is blue, orange and green. Okay. So its script is a space for Setosa, versicolor and virginica. Okay. In the flowers for is the iris. So in this tutorial, and you are completely created for the scatter plot Python using for the machine learning. Okay. So you are the mastered the art of scatter plots in Python and unlocking a visual realm that propels you forward in your machine learning endeavors. Okay. So keep visualizing, keep exploring. So thank you for watching. Hello everyone, welcome back to today's tutorial. We are diving into the fascinating world of linear regression, a fundamental techniques in matching in the machine learning that allow us to model relationships between four variables. Okay, so join me as we explore the theory behind the linear regression and the implementation each in the Python. Okay, so let's get started. So first of all, I am introduction to the linear regression in machine learning. Okay, so the machine learning, it forms the backbone of the predictive modeling, allowing us to make the prediction based on the relationships between variable. Okay, so either it's predicting house price or stock values or anything is between. So linear regression is our go-to tool. Okay, so the linear regression is two types. For is the simple and multiple. The simple line regression is modeling the relationship between two variables, and multiple linear regression is the extending the concept the multiple predictor variables. Okay, so now I am understanding the linear regression. So the linear regression is about finding the equation of a line that best fits our data. So the equation is the from for equal the y equal for mx plus b, where m is the slope and b is the y-intercept. Okay, so now I am implementing the linear regression in Python. Okay, so let's start it. So let's implement the linear regression in Python. So using the sklearn library, so one of the most powerful and user-friendly machine learning libraries out there. Okay, so first of all, I am implementing the linear regression in Python. So first create is from. Okay, and then create for is the sklearn dot model. Okay, it's model the selection. Then again create for is import for train and test split. Okay, so next create for from is create is the sklearn for dot is the linear is model for the linear model. Okay, then create for is import is the linear regression. Okay, so next again create for the import file is from, then again for sklearn dot create for the matrix. Okay, so it's matrix, then create for is import. Okay, and create the mean. Okay, so mean squared for error underscore error, and again create for the import file is import, then create for the matplotlib library. Okay, dot pyplot as plt. Okay, so last one I am import file create is the NumPy. Okay, it's NumPy as np. Okay, so now complete the import filing in this linear regression. Okay, so now I am generate some random data for demonstration. Okay, so let's create for np dot is create the random, then create for the sheet. Okay, so now I am create for the value is 42. Next time create for is the x equal to into its np dot for the random and dot is the rand Okay, it's a NumPy method for, then the value is 100 for 1. Okay. So now I'm again create for the next step is y equal to 4 is addition, then create for is 3 is multiplication, then create for x, and is the addition again for create is the np dot is random, then dot is the rand dn. Okay, so then the create is the value for is 100 for 1. Okay, so it's complete. And now I'm create for is the split the data into the training and testing set. Okay, so let's create. So first time create is the x for underscore is train. Okay, it's train, and then create for is the x for underscore test. Okay, and again create for is the y train. Okay, so y underscore train for the y underscore for test. Okay, it's test. So this is change for test. Okay, so it's complete. And now it's equal for is the train test split, then create for is the value is for x and y, and create for the test is the test size. So test size is equal for 0.2. Okay, so and then create for is the again create for the random. Okay, the random underscore state is 42 because it's the complete. Now I'm create for is a linear regression model. Okay, so create for is model, its model for equal the linear regression. It's the linear regression model. Okay, so next time create for is the fit the model through the training data. Okay, so create is model dot is the create for its fit, then create for the parenthesis is x underscore for train, and then create for the y underscore is train. Okay, so it's the fit for training data. Next time create for the make predictions on the test data. So create for y underscore is create for the predict PRED. So it's equal for that model dot is for predict is the value for its call is extreme data. Okay, so next time create for the visualize the regression line. Okay, so now I'm create for is the plt dot is the scatter. Okay, it's scatter, then create for parenthesis for x and y. So now I am create for is the alpha. Okay, it's alpha equal 0.7. Next create for is the level. Okay, it's create for the level equal, it's level equal single quotation create for is the original data. Okay, it's original data. It's complete this line, and next line I'm create for is the plt dot for its plot, then create for parentheses is create extreme, it's the x test, and create for the y prediction, and next create for the color, its color equal the color is single quotation create for is the red. Okay, and create for the its line weight. Okay, line, its line weight equal the single quotation for the crit is the linear regression. Okay, it's linear, it's regression. Okay, so next create for it's the complete for the linear regression line, and I am again create the its create for is PLT the scatter for y equal, okay, in the space. So this space for the alpha is 0.7 and the label the original data. So this line is complete. It's not error. So now I'm create for is the PLT dot title. Okay, its title. The title is the linear regression in Python. Okay, so the parenthesis for single quotation create linear regression in Python. Okay, so next line I'm create the x label for plt dot x label, then parenthesis single quotation create for x. Okay, so next line create for plt dot y label for y. Okay, it's y, and last line is create for is the plt dot I'm also create is the legend method. Okay, and then create for the show method. Okay, plt dot create is show method. Okay, so in this line are completed, but I am also created the calculate the mean squared error. Okay, so let's create. So first time create is the MSE. Okay, so it's the short form the mean squared error function. Okay, so create is equal, then create for the mean squared is the error is the scalar matrix regression. So the regression for create is the y for underscore test, and again create for the y underscore is the prediction. Okay, so now I am create for is the print function. Okay, so the print for if and create the single quotation create for mean squared error. Okay, is mean squared error. Okay, so the error is create for the index is MSE. Okay, so this code are completed. Okay, so now save this code and let me run this code. Okay, so just wait. Okay, so the result is printed. So here we generate for some random data for the split into its training and testing set. So create a linear regression model is fit to the training data, make prediction and visualizing the regression line. Okay, so the mean squared is the error is a matrix to evaluate how well our model is performing. Okay, so this is the result for in this tutorial. Okay, so here you are the congratulations are the mastered linear regression in Python. So a skill that opens the door to predicting future outcome based on historical data. So keep exploring, keep predicting, and keep your coding. So thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. We are diving into the realm of polynomial regression. an advanced technique in machine learning that allow us to capture non-linear relationships between variables. So join me as we explore the theory behind the polynomial regression and implement it in Python. Okay, so let's get started. So first of all, an introduction to the polynomial regression in machine learning. Okay, so the polynomial regression is while a linear regression models relationships with straight line, real world data, often the more complex is shown. The polynomial regression extends our capabilities by fitting curves to our data and enabling us to model intricate patterns. Okay, so it's great for the nonlinear regression and higher degree. So the capturing curves and bends in the data for nonlinear regression, and the higher degree is expanding the model's complexity with polynomial terms. Okay, so now in this polynomial regression is involved the fitting the equations of two data and allow us to the better capture to underlying patterns. Okay, the equations takes the form is y equal to b naught plus b1 x and b2 x whole square for bn for x power n. So in this equation are created for the polynomial regression. So here n is the degree of the polynomial regression. Okay, so let's create it. So now I am create the implementing the polynomial regression in Python. Okay, so it's implement the polynomial regression in Python using the is for sklearn library. The powerful library makes it the shameless to apply for the advanced machine learning technique to our data. Okay, so now I am create the generate some random for demonstration. Okay, so let's create np dot create is random and dot create the sheet. Okay, then the sheet is the value is 42. Next time create for the is x equal is 6 and multiplication np dot create is random and create for the rand value and parenthesis for 101 and it's the subtraction for 3. Okay, so next line I am create for is y equal to its floating point value 0.5, then create for is multiplication and the value is x, then its multiplication x and create for is double for multiplication 2. Okay, so it's line completed and now I will create for the addition plus x, it's addition x, it's plus for 2. Okay, so now I am create is the again for addition. Okay, then create for np dot is for random, then create for is the rand. Okay, so in this for numpy is dot random mrand. Okay, so it's create the value is 100 for 1. Okay, so its line are completed and next line I am create for the transforming the feature to indicate the polynomial terms up to the degree is 2. Okay, so let's create. So first time create is the poly. Okay, for short form is the polynomial, it's poly, then create for is underscore is the regression. Okay, so the equal for linear regression. Okay, so next line I am create for again poly and it's the polynomial regression dot create for the fit. Okay, then free fit for is the parenthesis create. So but I am not declare in this feature, so in this code next create first of all I am create the polynomial feature. Okay, it's poly underscore its feature features equal, then create for the is polynomial feature, then parenthesis create is degree. Okay, its degree equal 2. Then I am create for is include underscore base for false. It's false. Okay, it's capital word. And next time create for the is x for underscore, then create for poly, it's polynomial, then again create is poly underscore feature. Okay, then create for fit, and then underscore create for is the transform. Okay, so it's transform the x value. So now I am create for is a linear regression model. Okay, it's the poly underscore regression, then it's create for the x poly. Okay, x underscore poly, then create for y. Okay, so next line I'm create for is the visualize the polynomial regression curve. Okay, so first of all I am create x underscore is new. Okay, then create for is np dot is the land is for line scope. Its line for line scope is for starting for -3, then create the value is 3, then create for 100. Okay, and now I'm create for is the is ray scope for the in this code for self shape and order. Okay, so this line use for create is 100 and 1. Okay, so it's line completed. And next line I'm create for is x underscore for new value is underscore for poly. Okay, it's polynomial, then equal pol is again poly is features. Okay, the features dot create is for transform. Okay, is for transform for x underscore new parameter. Okay, so next time create for is the y underscore new. Okay, then it's equal for create the is polynomial underscore is the regression. Okay, then create for dot is predict for self x. Okay, so it's x new is for x new poly. Okay, so it's line completed. And next line I'm create for is the plt dot create the scatter. Okay, it's scatter, then the scatter for the value is x, and create for y, and then create for is alpha equal for 0.7. Okay, so next one I am create for is the its level. Okay, level equal the single quotation create the original data. Okay, its original data. Next line I am create for the is for transform x. Okay, so in this x for indicate. So now I am create for is the plt dot create for the plot. Okay, so now I am create for is parenthesis x for new, and also create for y underscore for new, and also create the color. Its color equal the single quotation create for and the green. Okay, so next line I am create for is the line width. Okay, its line width equal is equal for 2, and I am last one create for is the level. Okay, its level equal single quotation create the polynomial regression. Okay. It's regression. So this line completed, and I am create for is the plt dot title, then parenthesis for single quotation is this line. Now copy. Okay, it's copy and paste for inline. Okay, so the polynomial regression in Python. Okay, so this line completed, and I am create for is the x level and y level. Plt dot x level for parenthesis single quotation create is x. Okay, so now I am create for is plt dot for y level and then single quotation create for y. Okay, then I am create for is the plt is legend. Okay, it's legend. Then last one I am create for the plt dot show method. Okay, it's are completed. So in this tutorial I am create for the generate some random data for transform the features to indicate the polynomial terms and create a polynomial regression model and visualize the curve. So this allow us to how see how well the polynomial regression fits the data. Okay, so now save this code and let me run this code. So run. Okay, so just wait for a few seconds. Okay, so this is the result for the polynomial regression. Okay, it's create for the original data and then create for the red line is the polynomial regression. Okay, so in this for the x level data and it's the y level. So in the 0 indicate for x and in this the 4 for the y level data. Okay, so here we are the mastered polynomial regression in Python. So an essential skill for capturing nonlinear relationships in your data. So keep experimenting your code and keep turning this curve and your coding through. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. We are talking a deep into multiple regression, an advanced technique in machine learning that allow us to the model relationships between multiple variables. Okay, so join me as we explore the theory behind the multiple regression and implement it in the Python. Okay, so let's get started. So now I am introduction to the multiple regression in machine learning. So while simple linear regression model in relationships between two variables, first the multiple regression takes us further by enabling us to consider the impact of multiple predictors and our outcome variables. Okay, so this is a powerful tool for real world prediction modeling. So in these multiple predictors, modeling the influence of more than one variable, and real world application is predicting outcome based on several factors. Okay, so now the multiple regression extend the concept of linear regression by introducing multiple predictors. Okay, so now I am implementing the multiple regression in Python. So let's implement the multiple regression in Python using the sklearn model library. Is this library makes it shameless to apply advanced machine learning techniques to our data. Okay, so it's the created for in this impact file, and impact for is the pandas as pd, and also create is the linear regression, and again create is the mean squared error function. Okay, so now I am create for is the split the data into the training and testing set. Okay, so let's create. So first of all I am create the capital word x is equal, then create for the your. Okay, so let's get the your and underscore create for data set. Okay, then third braces create for the single quotation create is feature 1. Okay, then create the single quotation create feature 2. Okay, and I am again create for the single quotation create feature 3. Okay, it's feature 3. So it's line completed. So now I am create for each line are indicate for the all relevance. Okay, so now I am create for is the y equal, then create for its your underscore for data set. Okay, the data set is third braces create for the single quotation is the target variable. Okay, it's target underscore variable. Okay, so it's completed. Next on its line for the split the data into the training and testing set. Okay, so next on it's the split data, but I am in this line for first create is the split the data is training and testing set. Okay, so it's line created. So next line I am create for is the x train and then x test. So let's create it. So first time create is x underscore, then create for is train. Okay, it's train data, and also create for capital word x and underscore the create for test data. Okay, is test. So this code, this data are created, and I am create for is the y train. Okay, y underscore for train data and y underscore for its test data. Okay, so it's equal for the train test split data for is create, then parenthesis for x and y. Okay, and then create for is the test size for 0.2. Okay, and I am also create for the its random state. Okay, it's create for random state for 42. So now I am create for the creating a multiple regression model. Okay, so first time create is model is the create is linear regression. Okay, it's linear regression, and then create for parenthesis. Next line I am create for is the feed the model to the training data. Okay, so again create for model and dot is feed, and the feed is value is x for train data and create for the y train data. Okay, it's y train. Okay, it's line completed, and now I'm create a make prediction on the test data. Okay, so let's create for y and underscore for is the predict. Okay, it's predict is equal for the model. Okay, then create for dot is predict for x test. Okay, is x test data is x test. So next time create for the evaluate the model. Okay, so first time create is the MSE and is square is equal for the mean squared error. So then create the y test. Okay, y underscore test, and again create for y prediction. Okay, it's predict, and now I'm create for is the print function for if a single quotation create mean squared, it's mean it's a squared error. Okay, so then quotation and then is braces for MSE call. Okay, so here in this example we load our dataset split into training and testing data, and it's great for the training and testing set. Create a multiple regression model. Fit to the time is the training data. Make prediction and evaluate the model for the mean squared error. Okay, so in this code are connected for the polynomial regression, linear regression. Okay, so it's great for the it's multiple regression model. Okay, so here in this tutorial, you are mastered the multiple regression in Python, a skill that opens the door to predicting outcomes based on model factors, and keep experimenting your code and keep predicting. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. We are diving into a crucial aspect of machine learning, feature scaling. Join me as we explore the why and how of scaling features in Python for optimal machine learning performance. So let's get started. So the importance of feature scaling in machine learning. In the world of machine learning, not all features are created equal. Feature scaling in the process of normalizing or standardizing our features values to ensure fair play for each variable in the modeling process. Okay, so now I am create for in the and implementation for scaling in Python. Okay, so let's start it. So first of all, I am is also created for import for pandas and scalar, then it's the pre-processing import for standard scalar. Okay, so now I'm create for is the scale, its scale equal for is the standard scalar method. Okay, so now I'm create for is the df is equal for then pandas dot is the read underscore CSV. The database folder name is the heart CSV. Okay, so now I'm create for is the x is equal, then it's df for then third brace is create for single quotation for age. Okay, and next one create for is the sex. Okay, so now I'm create for is the scale is a scale for dx. Okay, so it's equal the scale dot it's create for feet, then it's feet for underscore the transform is x. Okay, so now I'm create for is the print function and print for is the scale dx. Okay, so now in this code are complete. Okay, so let me and in this code save. Okay, and let me run this code. Okay, so just wait, so it's processing. Okay, so this is the result for is the df for scalar. Okay, so this is the result for in this scalar standard scalar. Okay, so next step I am create for is the real world example for house price prediction for use the scale and the standardize. So let's apply feature scaling to a real world example for predicting house price based on the multiple features. Scaling ensures that each feature contributes proportionally to the prediction. Okay, so let's get started. So now in this code I am remove. Okay, it's code for remove, and now I am create for is the real world example and then create for the. So here in this create for I am the standard scalar used for the mean squared error and import for linear regression, and also create for is the import it test train test split. Okay, so let's create it. So first of all, I'm create the speech the data into training and testing set. Okay, so let's create it. So first of all, I am create for its df. Okay, its df is equal, then create for is the pandas dot is the read, then underscore is csv, and then create for is the single quotation, and I am used for in this database for home. Okay, it's home underscore data dot csv file. Okay, so now I am create for is the is x equal, then create for is df, and then double third braces first time create is the floors. Okay, so next time create for is the bedrooms. Okay, it's bedrooms, and third I am create for is the bathrooms. Okay, it's bathrooms, and now I'm create for is y equal for df, and then third braces for single quotation create is the price. Okay, so now in this pandas for I am import for the pandas. Okay, so it's imported. So next time create for is x train. Okay, it's x for underscore the train, and again for x is test. Okay, so next create for y underscore the train, it's train, and again create for y underscore is test. Okay, so it's equal the create for is equal the train test split for create is the x and y, and create for is the test size 0.2, and create for the it's create for the random state it's 42. Okay, so now I am create for is a standard scalar. Okay, so let's create its scalar. Its scalar is equal for the standard scalar for in this method, and next time create for the apply for standardization to feature. Okay, so first time create is x is the train and underscore for the scale is scaled for equal, then create for is the scalar dot fit is transform, the fit transform for x is train. Okay, so next time create for is the scalar in this code for same match. Okay, so in this code for copy and paste for next line this the x test. Okay, so in this for change there is x test. Okay, so complete this line, and now I'm create a linear regression model. So create the model. Okay, the model is equal for create is the linear regression model, and now I'm create for is the fit the model to the training data. So create is model dot is fit. Okay, then create for is parenthesis for x is train, and x train underscore for is the scaled, then create for is the y underscore train. Okay, So now I am create for make a prediction on the scaled test data. So create is y underscore for the predict is equal for the model dot is called the prediction. So the prediction for x test, okay, x test scale. So next line I am create for the evaluate the model, okay, evaluate the model for MSE is equal for the mean squared error. It's print for the mean squared error for the y test, okay, then y for predict, okay. So now I am create for is the print function, then print for f is single quotation create for mean, okay, mean squared its error, then create for is the third braces for MSE, okay. So now complete this code, okay. So here in this example we are predicting house price based on multiple features. Features scaling ensure that each feature contributes the proportionally to the prediction, okay. So now save this code and so now save this code and let me run this code, okay. So run, so just wait, so it's processing. So this is the result for is the mean squared error, okay. So in this for scale features are created, okay. So you are the mastered the art of features scaling in Python, a critical step for ensuring fair play among your features in machine learning. Keep experimenting your code and scaling, okay. So thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. We are delving into a fundamental concept in machine learning for training test splitting. So join me as we explore why dividing our data is crucial for building robust machine learning models and how to implement it using Python. So let's get started. So why use for the train and test split? So in use for the overfitting and generalization use, okay. So in our goal in this not just a fit a model to data but to be build model that can generalize well to new unseen data. For train test splitting helps us achieving exactly that overfitting and generalization, okay. So now I am introduction for is the train and test splitting process. So the train and the or test splitting process involves dividing our data set into two parts, one for training our model and the other for testing its performance. So this ensures that our model isn't just memorizing the training data but truly learning from it. So the training set is data used to train the machine learning model and training its testing set for the data used to evaluate the model's performance, okay. So now I am implementing for in this train or test split in Python, okay. So now let's get started. So now let's implement for is the train test splitting in Python using the in this method. So this library provides a simple and effective way to divide our data into the training and testing set, okay. So first of all I am used for the import, okay, import for NumPy, okay. So next I am create for is import for is the matplot library dot is pyplot as for plt, okay. So now I am used for the numpy dot is the random dot create for is the sheet in then parenthesis for 2, okay. So now I am create for is the is create for is the data set the x equal is then create for now I am create for is the split into the training set, okay. The training set should be a random selection of 80% of the original data. the testing set should be the remaining for 20%. Okay, so let's get started. So first time create is the train. Its train underscore x is equal for x, then create for 80%. Okay, so now I'm create for the train. Okay, the train for y is equal for the y, and then create for 80%. Okay, so next line I am create for in this code for copy and paste for next line. Just change is the test. Okay, is test for x, and then in this change for test for y. Okay, so but I am not it's declare for the x and y. Okay, so now I am create for in this line. So first of all I am create is x equal, then create for numpy dot is the create for random dot is for normal value is, then create for 3, 1 and 100. Okay, so next time create for is the y equal for the, then create for numpy dot its random value dot it's for create the normal, then value is for 150, then create is 40, and then create for is the 100. Okay, and it's divide for the x. Okay, so here and now I am create for is the display the training set. Okay, so the same as a scatter plot with the training set. Okay, so first of all I am creating the plt dot is the scatter. Okay, then create for is the train, it's train. So now I am create for is the train data. Okay, so it's for is train for x and the train for y. Okay, so now I am create for is the plt dot show method. Okay, so complete this code. Okay, and let in this code for save and let me run this code. Okay, so just wait. So as you can see the result is printed for is the in this result for in this for x train and y train. Okay, so this is the result for is the x for it's randomly created for x for 4.7 5 it and y for is the 2 5 point. Okay, so this is the result, and now I am create for a polynomial regression line through the data points in this test and training set. Okay, so let's create it. So in this tutorial I am first create is the import for numpy and then matplotlib library, and in this random for is this sheet for 2. Okay, so now I am create for is the my model use for numpy, it's polynomial regression use. Okay, so let's create. So first of all I am create is the my model. Okay, so my model is equal for the numpy dot is poly, then polynomial is in this line in this code for I am create for 1D. Okay, so now I am create for is the parenthesis and create for the numpy. Okay, it's numpy, and now I am create for the dot is the polyfit. Okay, so it's poly in this for line and paste for in this polyfit for the parenthesis for is train for x. Okay, and then create for is the train for y. Now I am create for is 4. Okay, next line I am create for the my line. Okay, it's my line equal for the numpy dot is the line space first 0 and 6 and 100. Okay, so in this line completed, and now I'm create for is the PLT. Okay, so PLT for also I am in this created, also created for the PLT dot scatter is X train and Y train, and now I am create for is the PLT dot for plot, and then create for the my line, and also create for the my model, and then parenthesis for call is the my line. Okay, so in this code are completed, and here the result can back my suggestion of the dataset is fitting a polynomial regression, even though it give us some weight result to predict the outside on this dataset. Okay, so in this code now I am saved. Okay, and let me run this code and just wait for in this code it's processing. So this is the result for changing for the previous output. Okay, so in this the result for the is polynomial regression using for the train is the x test and x train for y train. Okay, so it's for the complete output for in this tutorial. So here you are now the master the art of train splitting in Python, a crucial step for building machine learning models that can stand the test of new unseen data. Keep experimenting your splitting code. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. We are delving into the fascinating world of machine learning with decision making. So join me as we explore the intuitive natures of decision trees and learn how to harness their powerful using Python. Okay, so let's start it. So first of all, I am introduction to decision tree. At the heart of machine learning lies the decision tree, a powerful algorithm that minimizes our human decision-making process. So let's understand the basic of how decision trees work. So first is the decision trees that create the tree structure. It's the hierarchical structure of decision and create for the nodes and leaves. The nodes represent decision and leaves represent outcome. So how decision trees make decisions? So decision trees make decisions by branching out through a series of questions. Each node is the tree represent a question and the branch lead to possible outcome based on the answer to the questions. Okay, so it's great for the feature splitting. So nodes represent feature and the branch represent possible feature values. So optimal split for decision trees aim to make the most informative split at each mode. Okay, so now I am create for is the training a decision trees in Python. So let's implement a decision tree in Python using the splitlearn library. We will train the tree on a dataset and observe how makes decisions. Okay, so let's create it. So first of all, I am implementing decision tree in Python from its create the sklearn.tree. Okay, so now I'm create for is again import for the create is decision tree classifier. Okay, next I am create from then sklearner dot model, its model selection, and import the train test split. Okay, so next line I am create for from again the sklearn dot is create the matrix selection. It's only matrix. Okay, it's the matrix for input, then create for the accuracy score and create for in this confusion matrix. Okay, it's confusion matrix. So last one I am create for the import for pandas. Okay, it's pandas as PD. Okay, so its line are completed. So this workspace. Okay. So now I am create for the define features of its create the target variable. Okay. So next line I am create the load the data set is used for the iris data set. Okay. So it's create for its iris. Okay. Then is equal for the load. Okay. It's load underscore for iris. Okay. It's iris and then create parenthesis. So now I am define the features and target variable for is x equal, then create for the pd dot the create for is data frame. Okay. So the data frame create in the parenthesis for iris. Okay. It's iris for data, and now I'm create for is the column. Okay. So it's column equal, then iris dot it's create the feature, it's feature underscore name. Okay. So now I'm create for is y equal, then pd dot is create the series. Okay. It's series for then parenthesis create is the iris dot the target value. Okay. It's target. So next line I am create for is the in this for, so is import. Okay. So it's completed this line. So now I am create for the split the data into training and testing set. Okay. So first time create is x underscore the train. Okay. So then again create for x underscore the test data. Okay. So now I'm create for is y train and y test. Okay. So it's equal for the train test split for then parenthesis create x y and create for is the text size for 0.2 and create the is random status for 42. Okay, so it's line completed. So now I'm create a decision tree classifier. Okay, so short form is CLF is equal for the decision tree classifier. Okay, so now I'm create for is a train the decision tree on the training data. Okay, CLF dot create for is fit and then create for is parenthesis for x train and create for the y train. Okay. So now I am for making the predictions on the test data for y underscore read and is equal for the CLF dot is for predict then x text. Okay. X text for predict. So next line so is the double quotation create. So now I'm create the single quotations. Okay. It's a single parenthesis. So now I am evaluate the matrix. Okay. So let's create. So first of all I am create is the accuracy. Okay. It's accuracy equal then create for the accuracy score for its parenthesis for y for test and for y period. Okay. So next line I am create is the confusion matrix. So CONF for underscore its matrix its matrix is equal, then create for the its confusion matrix, then parenthesis create for y test and create for the y period its prediction. So this line are completed. Okay, so here in this example, create for the we load our data set is split it into training and testing set, creates a decision tree and tree classifier, train the model and make predictions and evaluates its accuracy using the test data. Okay, so now save this code. Okay, so just wait. So in this code for again save and let me run this code. Okay, so the result is printed. So here in this example for is the accuracy is 1.0 and the confusion matrix for this is the confusion matrix for in this data set for 1 0 0 0 9 0 and 0 0 11. Okay, so it's the confusion matrix for in this decision tree. So here in this tutorial, so you are now navigated through the world of decision trees in Python. So experiment with decision dataset, explore the in these trees for potential of this algorithm, and thank you for joining me in this exploration of decision trees in Python for machine learning. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. We are diving deep into the realm of model evaluation with confusion matrix. So join me as we unravel the insight it provides and learn how to implement it using Python. So let's get started. So first of all, I am understanding in this model for in the accuracy is just the tip of iceberg when it's come to evaluating machine learning model, and confusion matrix allow us to delve deeper, providing a comprehensive view of your model performance. Okay, so it's the confusion matrix create for is the true positive, true negative, false positive, false negative, precision, recall, and F1 score. So now is the component for in the confusion matrix for true positive is correctly predict positive indicates, and instance correct is the negative for the correctly predict negative instance, false and false negative create for the predict a positive value and negative value. Okay, so now I am implementing for is the confusion matrix in Python. So implementing a confusion matrix in Python is straightforward, especially with the help of sklearn. So let's see how we can do it. Okay, so I am is created also the confusion matrix for in this, so use for the random forest classifier. Okay, so let's create it. So now first of all I am create a synthetic data set for demonstration. Okay, so first of all I am create is x and y for is equal the make for classifier, and then parenthesis create for n dot is samples equal for 1000. Okay, so next time create for in underscore for the features for features is 10. Okay, and next line I am create for is in underscore, then create is for class is 2, and next line I am create for is the random state is 42. Okay, so this, so next line, so now I am create for is the split the data into training and testing set. Okay, so let's create it. So first time create is the extend. Okay, then create for is x test. Okay, so next line I am create for y train and create for y test. Okay, so it's equal for the train test split. Okay, The split is then parenthesis for x, y, and create for the text size is 0.2. Okay. So next line I am create for is the its random state for 42. So it's completed. So now I am create a random forest classifier. Okay. So it's the random forest classifier, and next line I am create the chain the classifier on the training data. Okay. So create for CLF dot its create feet. Okay. So then create for is x underscore the train, and create for is y train. Okay. So it's are completed. So now create for is make prediction on the test data. So y period is print, then equal for a CLF dot is the predict value is create for is x test. Okay. So it's for completed, and now I am create the confusion matrix. Okay. So CO it's an if it's the matrix is equal for the confusion matrix. Okay. So the confusion matrix create for y underscore test and y underscore for is spread. Okay. So it's are completed, and now I am create for is the print function. So first create is if, and then create single quotation, create the its confusion matrix, confusion matrix. Okay. So it's then backslash for n. Okay. So in the index for create the confusion matrix. Okay. So I am again create for the print function, then if and the single quotation create the classification. Is its classification report. Okay. Report then clone for then backslash for n, and then parenthesis in the created for the classification matrix report. Okay. So the report create for is the again for parenthesis for y test, and create for is the y print. Okay. So now in this code completely. So here in this example, we use a semantic dataset to create a classifier for random forest, train it, make prediction, and evaluate its performance using a confusion matrix and a classification report. Okay, so now save this code and let me run this code. Okay, so just wait. So this is the result for in this confusion matrix. So first time create is the confusion matrix for it's the 18 and 9, 15 and 96, and next create for is the confusion report for precision recall F1 score. Okay, so this is the result for in this tutorial. Okay, so it's create for is the totally confusion creates the classification report. So here you are now the master the art of the confusion matrix in Python, a powerful tool for understanding and improving machine learning model performance. Keep experimenting, keep evaluating. Okay, so thank you for watching and happy coding. Hello fellow learners, welcome back to today's tutorial. Today we are delving into the world of unsupervised learning with a technique known as hierarchical clustering. So join me as we unravel the hierarchical relationships within our data using Python. So let's get started. So first of all, I am understanding the hierarchical clustering. So the hierarchical clustering is a powerful unsupervised learning technique that groups similar data points into cluster. So unlike other clustering methods, it doesn't require specifying the number of cluster beforehand. So let's explore how it working. Okay. So but I am is in this is hierarchical clustering is defined for types of hierarchical clustering. Okay. So the most common types of the hierarchical clustering is the agglomerative approach. In this method is data point start as its own cluster and clusters are successfully merged until a stopping the criterion in mid. Okay. So it's created for the linkage method, single, complete, average and wires method, and the diagram create is the hierarchical tree diagram representing the clustering process. Okay. So now I am implementing the hierarchical clustering in Python. So it's the easy process. So it is the implement for the hierarchical clustering using the popular scikit-learn library. Get ready to witness the clustering magic. Okay. So let's start it. So first of all, I am create the implementation is hierarchical clustering in Python libraries. So first time create is the from. Then create for sklearn dot create for the data set. Okay. It's data sets. Then create for is import for make in these blobs. Okay. So now I am create for is the from and create for the type is typing. Then dot for is cluster dot is hierarchy. Okay. Then create for is import is create the then diagram is diagram and also create for is the linkage. Okay. So now I am again create for is import then matplot library dot pyplot as plt. Okay. So its our implementing is completed and now I am create a synthetic data for demonstration for create is x and in this dash it's underscore then create for is equal for make balls and then parenthesis for n underscore for sample is 300 and again create for is the centers for 4 and then create for the random state is 42. Okay. So now I am create for the perform the hierarchical clustering. So first of all I am create is the linkage for matrix. Okay. Linkage underscore its matrix then is equal for its the linkage method for x and the method equal single quotation create for average. It's average and next time create for the plot the dendrogram. Okay. So let's create it. So first of all I am create is the plt dot is create the figure. Okay. The figure is the fig size for 12 and 8. Okay. It's create then in this parenthesis and next one is closing. So next line I am create for is the dendrogram. The dendrogram is the linkage matrix. Okay. So now I am create for is the plt dot its title Then single quotation create is parenthesis for single quotation is the hierarchical clustering dendrogram. Okay, it's hierarchical, and create for is the clustering. It's clustering for dendrogram. Okay, it's dendrogram. And now I'm create for is the plt dot for x label, and then parenthesis single quotation for data point. Okay, next line I am create for plt dot for y label, parenthesis for single quotation create is the distance. Okay, and last one I am create for is the plt dot show method. Okay, so it's completed. So here in this for 12, okay, and in this, okay, so just I am check it for in this code. Okay, it's created are completely. So here in this example we create a synthetic data, perform the hierarchical clustering using the average linkage method, and visualize the process with a dendrogram using the matplotlib library and script view. Okay, so now save this code and let me, okay, so in this code and let me run this code. Okay, so just wait. So this is the result for hierarchical clustering dendrogram. Okay, so it's for create the size is 4 is 1 2 3 and 4. Okay, it's the data point, and in this 8 4 is the distance. Okay, so here in this are completely created. So you are now grasped the fundamental of hierarchical clustering in Python for is experiment with different data set and link is the in this just site. Okay, so in this for linkage and cut is height to unlock the full potential of this powerful unsupervised learning technique. Okay, so it's cross. So in this tutorial I'm completely created. Okay, so thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. Today we are diving into the world of classification with one of the most widely used algorithm for logistic regression. So join me as we explore its the intricacies and implement it with Python. So let's get started. So first of all, I'm understanding the logistic regression. So the logistic regression is a powerful algorithm for binary classification tasks. So unlike its linear counterpart, logistic regression is trial for predicting probabilities and making binary decision. So let's unravel the magic behind it. Okay, so the logistic regression, the function is transformed on any real value from into a probability score between 0 and 1. Here's the logic is created. So now I am create the logistic regression. The coefficient is the expected change in log odds of having the outcome per unit change in x. Okay, so let's understand. So let's use it create sometimes that makes more sense what. Okay, so now created for is the coefficient for in this logistic regression. Okay, so first time create is the import. For the import is NumPy. Okay, so next time create for is from the sklearn for its import the linear model. Okay, so now I am create for is the reshape for the logistic function. Okay, so create for x is equal then numpy dot is array. The array is the point for is something is 3 point 78, 2.34 and 3.56. Then create for is 2.09. It's 09. Then I am create for the is for 3 point. It's 2 point. And next time create for is the 0.14. Next line I am create for the 1.67. Then 2.56 is 69. So it's for comma. Okay. So next time create for is the 5.88. Okay. So now I'm create for is dot is the reshape is then parenthesis for -1 and 1. Okay. So it's line completed. So here I am create for is the y is equal for the numpy dot is array. The array is then third braces create for the 0 0 0 0 0. Okay. And now I'm create for is the 1 1. Okay. So it's completed. And now I'm create for is the logger logr is equal for the linear model. Okay. Its linear model dot create for is the logistic regression and then parenthesis. So next line I am create for is the is log r. Then create for dot is fit for the value is x and y. Okay. So now I am create for is the log underscore for odds is equal for is the log r dot is the coefficient. Okay. So the next create for is the odds and is equal the numpy dot is expect for then parenthesis create for is the log underscore odds. Okay. So it's got complete. And now I am create for is the print function. The print for is the odd values. Okay. So here in this code are completely. And now save this code and let me run this code. Okay. So just wait. So it's for error, but it's for something is mistake. So I'm just fixing this problem. So here in this code are in the problem for the numpy arrow I am is created for is all these value. Okay. So it's code this not run. Okay. So I am in created for in these values for created. So next line I am create for is previously create for 0 is 5 and in this is extra 0 is add and in this for its total for the 6 0 and 6 1. Okay. So again this code save and let me run this code. Okay. So just wait. So as you can see the result is printed for this is the result for is the coefficient value is 4.035 and something. Okay. So it's completed and now I'm create for is the probability. So the coefficient and interact values can be used to find the probability that is tumor is the tumor and cancers. So create a function that use the model is coefficient and interact values to return a new value. So this value represents probability that given is observed in a. So now I'm create for is the function. So let's create it. So to find the log odds for each observation, we must first create a formula that looks similar to the one from linear regression and extracting the coefficient and the intercept. Okay, so now create it. So I am is previous in this code. In this code use I am create for is the probability. Okay, so this value as same as, and it's create for the log fit for xy, and now I am create for is the another data. Okay, so first of all in this code now I am remove. Okay, so newly create is div and is create for the logits for 2 for probability, short form is prob. Okay, then create for is the logger for x. Okay, and then semicolon create for the, so I am this code are okay in this code same as. So now I am create for the div. Okay, so the create is logged to probe. Okay, so then create for is the logger for x. Okay, and then clone and create for is the log odds value is equal, then logger dot is the coefficient is star x, then plus for the logger dot is the intercept. Okay, intercept underscore and create for is the odds and is equal for the NumPy and create for is the except is parenthesis, the create is the log odds. Okay, and next line I am create for is the probability. Okay, its probability equal for the odds value, and then it's divide for parenthesis for on plus odds. Okay, so now I'm create for is the return value for then parenthesis create is the probability. Okay, and then print function I am create for is logist. Okay, is log, so I am not, it's either I. Okay, so it's logistic is then logistic to probability, the true probability first is logger and then create for is the x. Okay, so now complete this code. Okay, and save this code. So now let me run this code. Okay, so just wait. So this is the result for in this tutorial. So this the first is the 0.60. Okay, and in the result second for 0.19 something and 0.1277. Okay, so it's created for the probability for is logistic regression algorithm. Okay, so here you are just for equipped yourself with the knowledge to conquer binary classification challenge using the logistic regression in Python. So experiment, explore and apply the coefficient and probability for logistic regression. Okay, thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. So today we are diving into the art of hyperparameter turning, and our tool of choice is Grid Search. So join me as we explore how to optimize our machine learning models in Python for peak performance. So let's get started. So now what is Grid Search? So Grid Search is like a GPS for your model and helping her navigate the vast hyperparameter space. So it's extensive search that evaluate a predefined set of hyperparameter values to find the best combination for your model. So it's created for the systematic exploration of hyperparameters and define the grid of parameters values. Okay. So now I am implementing grid search in Python is Brace. So thanks to the skitlearn library. So let's see how we can use it, find the optimal hyperparameter for our machine learning model. Okay, so let's create it. So in this regression, I am used for the logistic regression model. Okay, so now I am create for is the Irish. Okay, so Irish dataset used for the data set, and create for is dot is load iris and then parenthesis, and next time create for is the x equal for is Irish. Okay, it's Irish for the data is single quotation is data. Okay, and the next line I'm create for y is the Irish and then target. Okay, it's target. So now I'm create for is the its logistic. Okay, so the logistic is equal for the logistic regression, and now I am create for in this regression for its parenthesis for is the max iter is it's 10,000, and next line I am create for is the print for is logist dot is fit, and then the value is x and y. Okay, so now I am create for is the print function. So print for is the logistic dot is create the score for its x, okay, and y. So these code are completely, and here we with the default setting of c equal to 1. Okay, so now save this code and let me run this code. Okay, so just wait. So this is the result for in the logistic regression. So use setting of c equal to 0, we achieve a score of 0.973. Okay, so now let's see if we can do any better by implementing a grid search with difference value of 0.973. Okay, so now I am implementing the grid search. We will follow the same step of before, except this time we will set a range of values for C. So knowing which values to set for the search parameter will take a combination of domain knowledge and practice. Okay. So now since the default value for C is 1, we will set a range of values surrounding. Okay. So now started. So first of all, I am in this code for use and just is create for the c equal, then the value is 0.25, next is 0.5 and 0.75, and then create for 1, and in this code in this value for copy and paste. So just change it is 1.25, 1.5 and 1.75, and last one is 2. Okay, so it's completely, and now I am create for is the scores is equal, then empty third braces, and now I am create for the for loop is the choice in C, and then clone create for is the logistic dot is set parameters for is C equal choice, and next line create for the logistic dot is fit, then fit value is x and y, and next line I am create for is the scores dot append, then logistic dot score for x and y. Okay, and last one I am print function use and print for the scores. Okay, so now in this code are completed. Okay, so we can see, so save this code and let me run this code. So just wait. So as you can see, the result is printed. So here we can see that the lower values of C performed worse than the base of parameter of 1, and however as you increase the value of 2 is 1.875, then the model is experience increased accuracy. So it's same, it changes for in this previous is 0.97 something and is the 0.66 is 6 something. So this result for 0.966 and in this for 0.973. Okay, so it's great for the value is 0.98, 0.98. Okay, so last one is created for in this the value 0.98 something. Okay, so here the complete implementing the grid search used for the logistic regression algorithm. Okay, so here in this example I am create for the logistic regression use grid search. So we are unlock the scratch of hyperparameter turning using grid search in Python. Remember the journey doesn't end here and experiment the different model grids and data sets. Okay, so thank you for watching and happy coding. Hello programmer, welcome back to today's tutorial. We are delving into the world of categorical data and how to handle it effectively for machine learning. So join me as we explore the tools and technique to turn categorical chess into machine learning gold. Okay, so let's dive in. So first of all, I'm understanding the categorical data. So the categorical data such as colors, genes, or the label adds richness to our data set. So, however, machine learning models prefers numbers over words. Let's decipher the categorical code and make it ML friendly. Okay. So, in this tutorial, I am create for the technique for categorical encoding. So, the encoding is the magic wand that transforms words into numbers. So, let's explore popular encoding techniques to make our categorical data machine readable. Okay, so now I'm create for is a level encoding and the on hot encoding. Okay, so let's start it. So the level encoding is like the giving its category a technique a unique ID. Let's see how to implement level encoding in Python for a shameless transformation. Okay, so first of all I am create is a level encoding from then sklearn dot is pre-processing, then import for is the its level encoding. Okay, so now I'm create a level encoder object for its level underscore the encoder. Okay, so is equal for the level encoder. And now I am example data with the categorical features for its colors equal then red and the color is green. Next one is the blue and again color yellow, and the color is red. Okay, so here it's completed, and next line and feed the transform the data using level encoding. So first create the encoded. It's encoded underscore colors is equal for the level encoder dot feed, and its feed for the transform is colors. Okay, and now I'm display the result for first time create is print function, and if for single quotation create the ordinal colors. Okay, ordinal colors for the color is then index for the colors, and next line I am again create for is the print for if, and single quotation create is the encoded color, its colors, then clone, then index for the encoded colors. Okay, so now complete this code, and here in this example we use the level encoder to transform a list of colors into numerical representations. Each color gets a unique label. Okay, so now save this code and let me run this code. Okay, so just wait. So it's error, but why? So it's fixed for in this problem. So now I am again save this code and let me run this code. Okay, so just okay, finally it's printed. So this is the result for is the categorical data for is the first time create the level encoded data. So it's the color for red, green, blue, yellow, and red, and the encoded color for is the 21032. Okay, so it's created. So next time create is the on hot encoding. Okay, so let's create it. So the on hot encoding in Python is the go-to for categorical features with no inherent order. Let's see how it turns categories into binary columns, making our data hot and ready for ML. Okay, so let's start it. So first of all, in this code I am now remove. Okay, so first time create is import for pandas, then as for PD. Okay, so next time create for example the data categorical feature for the genie. Okay, is the data, then is equal for the curly braces, then single quotation is the genre. Okay, then create for is clone, and then index for first create is the action, and next create is the comedy. Okay, it's comedy, and again create for the drama, it's drama, and again create for is the action, and then create for is the again comedy. Okay, it's created, and now I'm create for is the df is equal for pd dot is create for the data frame for is parenthesis for data. Okay, so now I'm used for pandas get is demystify for hot on hot encoding. So create is the on underscore hot underscore for the encoded is equal for the pd dot is get its dummies and then create for is df, then create for the single quotation is the January, okay, and then create comma, and the prefix for single quotation is January, okay. So now I am display the result is original data for single quotation is clone, then new line for is df, okay. So next line is create for the, in this code for remove is on hot, it's encoded data. So in this for remove, so it's new line, then third braces for on hot encoded, okay. So in this example, we use a pandas get dummies to perform on hot encoding on a data frame with a generic column. So each category becomes a binary column, okay. So now save this code and let me run this code, okay. So just wait. So as you can see, the result is printed. So it's for the original data is January, 0 for action, 1, 2, 3, 4, 5 is the comedy, drama, action and comedy, and the on hot encoded data for in this this is the data for in this on hot encoding, okay. So in this tutorial, you are the data magician, so you are unlock the secret of handling categorical data in Python for machine learning. Remember, every category tells a story, and with the right encoding, your models will hear it loud and clear. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. Today we are diving into the fascinating world of k-means clustering, a powerful technique for grouping similar data points together. So join me as we unravel the stories of clustering and unleash the potential of k-means in Python. So let's get started. So first of all, I am understanding the clustering. So clustering is the art of grouping similar things together. Imagine organizing your wardrobe, shirts and shirt is the together is the today we are focusing on of the most popular clustering algorithm k-means. Okay, so you imagine the organizing your wardrobe for shirts with shirts and pant with pant. Okay, so now I am create is the most popular clustering algorithm k-means. Okay, so first of all, I am understand the k-means algorithm. So the k-means has a straightforward process. It's like for of total points and contrasts its centroids. So let's unravel the step of the k-means algorithm from initializing to convergence. Okay. So first of all, I am create is the k-means in Python. So time to bring k-means to life. Let's implement the algorithm in Python using the scikit-learn library. So get ready to witness the magic of clustering. Okay. So first time create is the from. So it's the from and create for the sklearn for dot is cluster. Then create for is import for its k-means. Okay. So now I'm import for NumPy. Okay. Then NumPy as np. Okay. So now I am create for is the sample data. np dot is the random dot is sheet is 42. Okay. Next line I am create for the data underscore for points is equal. Then np dot is the random dot is rand in, then the value is 102. Okay, and then equation is into is 2 and then plus for np dot array. Okay, is array, and then array for is the third braces create for 5 and 6. Okay, so now I'm create is k-means model with 3 cluster. Okay, so first of all I am create is the k-means. K-means is equal for the k-means, and then create for is n underscore is cluster equal for 3, and again create for is the random state is 42. Okay, so it's line completed. And next line I am create a k-means, it's the fit the model to the data. Okay, so create the k-means. Okay, and then dot is fit for is the only fit. Okay, so then create for is the parenthesis is the data underscore points. Okay, so next line I am create the get cluster labels and centroids. Okay, so create for the labels is labels equal for the k-means dot is labels underscore, and next line I am create for is the is centroids. Okay, its centroids is equal for the k means dot is cluster. Okay, so cluster is center. Okay, so it's are completed. And now I'm create the display the result. So first time create is the print, and then create for is if for single quotation create is the cluster. It's cluster levels clone, and then new line create in this index for the labels. Okay, so next line I am again create for print, and F for is the single quotation create is the centroid as centroids, and then clone for create the new line, and then is curly braces create is the centroids. Okay, so now complete this code, and here in this example, we generate the random data points and use the sketchlearn k-means class to perform clustering into 3 clusters. And we then extract the cluster labels and centroids. Okay, so now in this code for save, and let me run this code. Okay, so just wait. So as you can see, the result is printed. So this is the cluster label. Okay, and in this for next line is create the is centroids. Okay, so this is the result. Okay, so in this for the centroid results. So now in this tutorial I am also create for is the visualizing for k-means result. Okay, so understanding k-means is one thing, but visualizing the result is another level. So let's create a visual representation of our clusters to truly see the power of k-means. Okay, so let's start it. So in this code, so now I am remove. Okay, so now I am is create is the import for the matplot library dot is the pyplot and as plt. Okay, so now I'm create plot the data points of and centroids. Okay, so first time create is plt dot is the scatter. Okay, and scatter for is the data, its data underscore, then create is the points. Okay, let's create its points, and then create for is the third braces is clone for 0. Okay. So now I am create for the, so suppose in this code I'm now remove and back for in this previous code. Okay. So in this code, and now I am create is import for the, its import, then create is again matplot library is the pyplot as plt. Okay. So now I am create the, is first create in plt dot is the scatter, and create for is the data points, and the data points, then third braces clone and then 0. Okay. So now I am create for is the data points for again in these braces and clone for 1. Okay. So next I am create for the is c equal is create the its labels, then create for is the cmp cmap is equal, then single quotation create is the very, it's very and these. Okay. So next time create for the in this for the s equal is s equal, then single quotation create is the 50, and next create for is the alpha. Okay, it's alpha equal 0.7. Okay, so in line completed, and now I'm create for is the plt in this, so in this code for copy. Okay, and paste for in this line. Okay, so now I'm just change it is the, it's the centroids, and this data change for the centroids. Okay, so the value is same as, and this in this c for the color is single quotation for create is the red. Okay, so next create is the marker. Okay, in this code for remove, and just create for is the marker is equal for, then single quotation create for x. Okay, so the s is for 2000. Okay, and then create for is the level. Okay, it's not alpha, it's for level. Okay, so it's the levels, its level equal, then single quotation create is the its centroid. Okay, its centroid. So these are completed, and now I am create for is the plt dot title. Okay, so the title is for single quotation create for is the k means clustering. It's clustering, and now I'm create for the is plt dot is x level. The x level for is parenthesis for single quotation create is the its feature 1. Okay, and then again plt dot y level create for the single quotations create is the feature 2. It's feature 2, and then create for is the plt dot is legend method, and last one create for is the create is show. Okay, it's show method. So now these code are completed, and here in this visualization we use the matplot library to plot the data points with different colors based on their assigned cluster. Okay, so the red X markers represent the cluster center. So now save this code. Okay, and let me run this code. Okay, so just wait. Okay, so The result is printed for is the clustering levels in this same match. Okay, so in this code I am just created for is the visualizing for the k maps. Okay, so here in this tutorial, so you are the data directives is detectives for the you are the mastering the art of k-means clustering in Python. So remember, every cluster tells a story, and with k-means you are the storyteller. And if you found this video helpful, okay, so thank you for watching and happy coding. Hello fellow learners, welcome back to today's tutorial. Today we are diving into the world of bootstrap aggregation or simply bagging. So join me as we explore this powerful assemble learning technique that can superchange your machine learning models. Okay, so let's get started. So first of all, I'm understanding the bootstrap aggregation. So the bootstrap aggregation or bagging, it's a technique that enhance the stability and accuracy of machine learning models, and it works by training multiple instances of the same model on different subset of the training data. Okay, so this diversity in training leads to a more robust and generalized model. Okay, so I'm almost is created for time saving for in this implementing for in this import file. Okay, so now I am let's firstly started the implementing bagging with scikit-learn. Okay, so let's get started. So in this bagging tutorial, so I'm using for the decision tree. So a popular choice for this technique in scikit-learn. Okay, so now I am generating the semantic is data set. So replace with your actual data set. Okay, so now I am in this use. So first time create is x and y. Then create is equal for is the make underscore classification. Then create for is n underscore is the sample is 1000. Okay, and next time create for is the n features for is 20. Next one I am create for is the is n underscore for is the informative it's 10. Okay, okay, so next create is the n underscore is classes for is 2, and last one is create for is the random state is 42. Okay, so its line are completed, and next line I am create for is the splitting the data into training and testing set. Okay, so let's create it. So first of all I am create is the x underscore train. Okay, so then create for is the x underscore for is the test, and as usual create for is the y train, y underscore train, and the y underscore for test. Okay, so is equal for is the train test split, and then parenthesis for create is x and y, and next create for is the text size for 0.2, and then create for is the random state is 42. Okay, so it's line completed, and now I'm create for a base decision tree classifier. Okay, so first of all I am create is base underscore model is equal for is the decision tree classifier, and then parenthesis create for is the random state is 42. Okay, so next line I am creating a bagging classifier with 50 base model. Okay, so first of all I am create is the bagging. Okay, it's bagging is double bagging, it's the bagging, and then underscore for the model. Okay, it's model equal, then create for the is for bagging classifier, then parenthesis create for first create is the base model, and next create for n underscore estimators, the estimators is 50. Okay, so next create for the random state is 42. Okay, so its line it's created for is the 42. So next line I am create for the training the bagging model. Okay, so now I am create for is the bagging model dot fit. Okay, then create for is the x train, then create the for y train. Okay, so its line completed, and next line I am create for is the making prediction for y underscore is spread is equal, then create for is the its bagging model dot is the predict for x test. Okay, so now I am create for is the accuracy for evaluating the model. Okay, so its accuracy is equal, then create for is the accuracy score, then parenthesis create for y test. Okay, and create for is the y period. Okay, so now I am create for is the print section, and then F for single quotation create for is the accuracy, its accuracy, and then clone and the curly braces create for is the accuracy. Okay, so now here in this example I am create we generate a synthetic data set, split it into training and testing set, create a base decision tree classifier, and turn them using bagging to then 50 models. So finally we evaluate in this. So let's save this code. Okay, so save this code and let me run this code. Okay, so just is processing. Okay, so finally we evaluate the performance of our bagging model, and this is accuracy is the 0.91. Okay, this is the result. So here and there have it, the bootstrap aggregation, a powerful technique to amplify the performance of your machine learning model. And if you found this video helpful, okay, so it's are the embrace the beginning, it's bagging magic. Okay, so thank you for watching and happy coding. Hello programmers, welcome back to today's tutorial. We are delving into the realm of model validation, and our guiding light is cross-validation. So join me as I explore why cross-validation is crucial for building robust machine learning models and how to implement in Python. Okay, so first the challenge of model validation. So building machine learning models is like for embarking on a quest. The challenge lies not just in creating a model, but it's ensuring its robustness and reliability. Okay, and that is where model validation comes into play. Okay, so now I am introduction the cross validation. So the cross validation is a technique that helps us check the validation code by training and testing our model on different subset of the data. So let's understand how it. Okay, it's tutorial I am creating for the cross validation in Python. Okay, so it's unleash the power of cross validation in Python using Learn is most popular libraries. Okay, so first of all I am create is from. Okay, it's from, then create for is the sklearn and create dot model. Okay, it's model selection, then create for is import for is cross validation score. Okay, so next line I am create for from, and again for sklearn is sklearn for dot is create the data set and import for load iris. Okay, so next line I am again create for from, and then create for is sklearn for dot is the neighbors, and is import for is the kneighbors classifier. Okay, so it's a completed, and now I am loading the iris data set. Okay, so first of all I am create is the iris. Okay, so it's not its classifier. Okay. So first time create is the Irish. Irish is equal for the Lord Irish, and next line I am create for is X and Y. Then it's double space. It's the Y. Okay. So it's equal for the Irish dot. It's the data, and then create for is the Irish dot its target. Okay. Its target. And now I'm creating a k nearest neighbor classifier. So first of all, I am create is the KNN is equal for the k nearest neighbor classifier, and then parenthesis for n underscore is neighbors for 3. Okay. So next line I am create and applying for the 5-fold cross validation. Okay. So first of all, I am creating the CV and underscore, then create is the CV means for class validation score is the scores is equal for create is the class validation for is KNN, and next create for is create for X and Y, and then create for is CV equal 5. Okay, so it's completed. And next line I am create for the displaying cross validation score. So first of all I am create is print and create for single quotation create is cross validation scores is an index for CV scores. Okay. Next line I am again create for print and single quotation for is the main CV section, and then index for the CV scores name. So it's created. So then create for is CV scores dot is mean and then parenthesis. Okay. So now complete this code, and here in this code snippet we load the iris dataset, create a k nearest neighbors classifier, and apply for 5-fold classifier in this cross validation. So the scores provide insight into the model's performance on the different subset of the data. Okay. So now save this code and let me run this code. Okay, so just wait. So as you can see, the result is printed is the cross validation scores, and in this for the mean CV scores. Okay, so this is result are printed. Okay, so here in this tutorial, and there you have it, is cross validation, the key to mastering model validation in Python. So the start are applying for the cross validation to your models and witness the transformation. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. Today we are navigating the sets of model performance and our compass is the AUC ROC curve. Okay, so join me as we explore the significance of this curve in evaluating the classification model and how to set cell width in Python. Okay, so let's embark on this journey. Okay, so first of all, I'm discuss for is the model evaluation. Okay, so the accuracy is often our guiding star in evaluating models. It's great for the AUC for ROC curve takes as B1 accuracy, providing a more comprehensive views of a model performance. Okay, so let's create for is the binary classification scenario. Okay, so decoding for AUC ROC curve is like a navigation chart for our model. is helping us understand how will they distance for between classes. So let's decode this chart and understand its components. Okay. So now let's see is start for soil with Python coding using scikit-learn. Okay, so in this import file is the necessary libraries it's almost created for is the time saving, but in this tutorial its code for is too long. Okay, so now I am this part is generating the synthetic data set. Okay, so first time create is the x and create for y and is equal for the make classifier and then create for ensemble for is 1000 and next create for is the in features for is 20 and next line I am create for is the n classifier is 2 and last one create for is the random state is 42. Okay, so next line I am splitting the data into training and test set. Okay, so first time create is the x train and create for is the x underscore test. Okay, so in this code for copy it's copy and paste and just change it for in this y and in this for y. Okay, so it's for equal then create for is the train test split. Okay, so this split, so first time create is the x and y and the text size is 0.2 and then create for is the random state is 42. Okay, so next line I am create for is the logistic regression model. So first of all I am create is model is equal for the logistic regression and then parentheses and last in this create for the training the model. Okay, so first of all I am create is the model dot is fit. Okay, so the fit for is x train. Okay, then create for is the y train. Okay, it's completed and now I'm create for the getting predicted probabilities for y for prob is equal for is the model dot is the predict. Okay, the predict for in this first time create is the model logistic regression and model fit for x and y and getting predict for y predict for model dot is predict and I am create for is underscore that proba in this for x train. Okay, it's not x train, it's used for x test and then create for third braces and semicolon for 1. Okay, so A's are completed and now I'm create for calculating the ROC curve. For first of all I'm create is FPR and then TPR is and then create for is the threshold. Okay, it's the trace is trace as threshold is equal for the ROC underscore curve then single quotation create for is the y text and then y is prob. Okay, so it's line completed and now I am calculating the AUC. Okay, so first of all I am create is the ROC underscore for AUC. Okay, is equal for the AUC then parenthesis for FPR and the TPR. Okay, so it's are completed. Now I'm create for is the plotting the ROC curve. Okay. So first of all, I am creating the plot dot is the figure. The figure is the figure size for 8 and 6. Okay. So next line I am create for is the PLT dot is the plot and then parenthesis for FPR and TPR and create is the color equal, then single quotation create is the dark orange. Okay, it's dark orange and create for is the LW equal for 2 and next create for is the level equal for, then create F is single quotation create for AUC and is equal for, then curly braces, then create is the ROC for underscore AUC and clone for 0.2. It's the floating point and its line completed, and next line I am create for is the PLT dot is for plot and then parenthesis single quotation and it's not single quotation, the third braces for 0 1 and again create for 0 1. Okay, and then create for is the color equal single quotation for navy, it's navy and then create for is the LW is equal for 2. Okay, and then create for is the line style. Okay, it's the line style equal single quotation for is dash. Okay, so it's line completed and now I am create for is the in this for the value is the single quotation inside. Okay, so it's completed. So now I am create for is the plot dot is x label. The x label for is single quotation create is a false positive rate. Okay, false positive rate and in this code for copy. Okay, and next line I am create for is the PLT dot is y label single quotation and paste for in this, so is single quotation. Okay, is the parenthesis, so it's for the true, it's true. Okay, it's true and then create for is the PLT dot is then title. The title is ROC curve. ROC curve and I am create for is the PLT dot is the legend and then method create for is the LOC is equal for, then single quotation is the lower right. Okay, lower right and last one I am create for is the PLT dot is show method. Okay, so now complete this code. In this tutorial I am create for the generate a synthetic data set, split it into the training and testing set and create a logistic regression model and plot the AUC ROC curve to evaluate its performance. Okay, so now save this code and let me run this code. Okay, so just wait. So as we can see the result is printed. So this is the ROC curve and it's the false positive rate and it's the true positive rate. And this is the AUC, the point is the 0.92. Okay, it's the accuracy. So here in this tutorial, and there you have it, the AUC ROC curve, your chart for navigating the search of model performance, and the chart the success of your models with the AUC ROC curve, and may your predictions be ever accurate. Okay, so thank you for watching and happy coding. Hello everyone, welcome back to today's tutorial. We are diving into the realm of machine learning, and our focus is on a versatile algorithm for k-nearest neighbor. So join me as we unravel the power of KNN, understand its inner working. Okay, it's implement it in Python. So let's embark on this journey. So first of all, I am discuss and understand is the k-nearest neighbor is the imagine having helpful for neighbors in your data landscape is the essence of the k-nearest neighbor is versatile and initiative algorithm. It's made for decision based majority. Okay, so how KNN works, it at the heart of KNN is the concept of neighborhood consensus, and when focused with a new data point, and KNN looks at its for k-nearest neighbor to make prediction. Okay, so the majority vote determines the outcome. Okay, so let's deep into the mechanism. Okay, so I'm almost create in the is necessary import libraries. Okay, so now I am leading for in this tutorial I am used for Irish dataset. So first time create is the Irish. Okay, and is equal for the load iris. Okay, so next one I am create for x, and y is equal for the iris dot is create data, and create for is the iris underscore target. Okay, all algorithm is the same process created. Okay, so just its simple changes. So now I'm create is the splitting the data into training and testing set. Okay, is the same as for previous tutorial. Okay, so first of all I am create is the x for train and x for test. Now y for train and y underscore is test. Okay, so it's equal for is the train test split, then the value is for x and y, and the text size is 0.2, and then create for is the random state is 42. So next line I am create for the mistake is dot. Okay, so is for error is solving. So in this line I am create a k-nearest neighbor classifier with k equal to 3. So KNN is equal for the k-nearest neighbor classifiers, and then parenthesis for is n neighbors is 3. Okay, so now I am create for is the training the data for KNN dot is the fit, then x for train and y is train. Okay, so next line I am create and making prediction for y underscore for pred is equal for the KNN dot is the predict for x test. Okay, so now I am create and calculating the accuracy. It's the accuracy is equal for the accuracy score. The call is for y test and y for predict its prediction. And now I am print function use, then print for a single quotation, create is the accuracy is accuracy, Then clone and call for index is the accuracy. Okay, the accuracy, and clone for point is 2f. Okay, so it's are completed. And here in this code, we load the iris data set, split it into training and testing set, create a k-nearest neighbor classifier with k equal to 3, train the model, okay, and make prediction and calculate the accuracy. So now save this code and let me run this code. Okay, so just wait. So as you can see, the result is the accuracy for 1.00. Okay. So this is the result for in this carrier nearest neighbors algorithm. So and there you have it, the power of k nearest neighbors. If you found this video helpful, okay. So it's our create the embrace the neighbors in your data landscape with KNN and may your prediction be ever accurate. So thank you for watching and happy coding.